are doing section 2.10, the last section in this chapter. And this is percent change. So first we're going to start with the formula for percent change. It is the absolute value of the original, so the original number, the original amount, minus the new one, both inside the absolute value, divided by the original, and then we times it by 100. So here's example number 1. Let's say our original, it's going to have a little colon in your book. Maybe the original is 6, and the new is 8. We're going to start by making an absolute value. The original 6 minus 8 inside the absolute value, divided by the original, we're going to times by 100. So 6 minus 8 is negative 2. The absolute value of negative 2 is 2. 2 divided by 6 is 0.333 times 100 equals 33.3%. Now the second part to this is, do these numbers go up or do these numbers go down? They go up. So that is a 33.3% increase. You're going to need to put whether it's an increase or a decrease. Just a second. So to save you a little bit of writing, after your percent, you can draw either an arrow up, or if it's a decrease, you can put an arrow pointing down. Okay? Example number 2. So this is exactly what you have to do in today's homework for problems 8 through 17. It'll actually write original with a colon, and maybe it gives you 2,100. And then the new with a colon is 1,500. So we're going to put it in our formula. We have the absolute value of the original, 2,100, minus the new, 1,500, divided by the original, then we times by 100. So 2,100 minus 1,500, this is 600. 600 divided by 2,100 is 0.2857 times by 100 equals 28.6%. Is this an increase or a decrease? It is a decrease. From the original to the new, it goes down. No, there's still more. I'm only up to 17. There's more to it. I want to do one more example and make sure we're understanding exactly how this works. Example number 3. The original, let's say, is 175. The new is 235. Find the percent change. So inside the absolute value, Andrew, tell me what we got. Good. And tell me, Marley, what are we dividing by? Good, 175. And we're timesing by 100. Inside the absolute value, 175 minus 235 is negative 60. But it's inside the absolute value, so what does that mean? positive 60. 60 divided by 175. 428 times 100 equals 34.3. I'll let you round to the tenths percent. And is this an increase or a decrease? It is an increase. It goes from 175 to 235, so it goes up. Do we have any questions on percent change? Now we have to talk about percent error. Percent error is how much, if you're estimating somebody's weight, height, age, it's that percent of error that you could be off from what they actually are. Okay? So here's the formula we're going to use, very similar to percent change. We're going to have the absolute value of actual minus the estimate divided by the actual times 100. Basically the same thing. Example number 4. All right. So let's see if we can't put this into practice. You estimate your friend's weight to be 142 pounds. She is actually 153 pounds. Find the percent error. All right, so we start by doing the actual. What number up there is the actual amount of her weight? 153 minus the estimate of 142 divided by the actual of 153, then we times by 100. So first of all, we have 11, right? 153 minus 142 is 11. 11 divided by 153. 0.0718. All right. So that means when I times by 100, I get 7.2% error. Then then it's not an error, is it? Okay. All right, example number 5. So this percent error has to do with problems 18 and 19. You estimate your friend's height to be, how about, let's go 6'10"? All right, so that's 70 inches. He is actually 7'1", really? All right, he is actually 6 feet 10 inches. I don't know. So, huh? Oh, he said he was 6'10". Well, that's actually, I have him at 5'10", don't I? Yeah, that's 5'10" right now. You want him at 6'10"? All right, let me change my 70. That would be 82 inches, right? Okay. times 12 is 72 plus 10, right? Okay. And then he is actually 7'1". All right, 7'1". So that makes him 85 inches. Find the percent error. Hey, be nice. All right, so actual is 85 minus the estimate of 82 divided by the actual 85 times by 100. So we get 0.03529 times 100 gives us 3.5% error. All right, so any question on percent error? Okay. I still have 3 more problems to talk about. Thank you. The last 3 problems are something a little bit different. They have to do with when you're measuring something, how much you can be off and it still be acceptable. So the example I always use is when something's being made at a factory, right? If you're making a part, you want the part to be a certain size, but you can still accept it if it's maybe a couple millimeters bigger or a couple millimeters smaller, right? So there's a little bit of a range of where the part is still good. So what we're going to find is max and min, like the biggest it can be and the smallest it can be, of a certain number, okay? So that's what we're talking about next. So we're going to say, how do I want to, I want to call this possible measurements this time. When we are looking for the possible measurements, we are going to take the minimum minus the possible error sorry, that's not what I meant to say. Let me rewrite that. I said that wrong. I apologize. Minimum should be the measured minus the possible error. I apologize for that. All right. If I want the maximum, I'm going to take the measured amount plus the possible error. All right, so first we have to talk about what possible error means, okay, before we get into that part. When we talk about possible error, we are going to take the smallest unit and divide by 2. Okay, so for example, let's say I measure something and it's 231. My smallest unit of measure is the ones column. So I would take 1 and divide by 2. That means I can be off by plus or minus 0.5. Okay? Let's say I measure something and I measure it to be 3.4. The tenths column is my smallest column. So I'm going to take a tenth, which is 0.1, and divide by 2. That means that I can be off by plus or minus 0.05. Let's say I measure something and it's 33.75. This time my smallest measurement is in the hundredths column. So I take a hundredth and divide by 2, so I can be off plus or minus 0.005. Okay, so this is the first thing. We got to make sure we're understanding this concept. Okay, so you look to the right. Whatever place the placeholder it is in, right? You take that value and divide by 2. So like this one is in the 1 spot, I divide by 2. This one is in the 10th spot, so I divide by 2. This one is in the 100th spot, so I divide by 2, right? So whatever the last digit is, you take that value, that spot, and divide by 2 to be your possible error. Okay? So let me show you how this works. Here is example number, I don't know, am I on 6? Thank you. Example 6. An ostrich egg has a mass of 1.1 kilograms. Find the minimum and maximum possible measurements. All right, so first of all, we're going to look at this actual measurement of 1.1. This 1 is in which column? The 10th column. So I take 1/10 and divide by 2. My measurement can be off by, exactly, 0.05. So now, to find my minimum, I take my measurement, which is 1.1, and I subtract 0.05. 1.1 minus 0.05 is 1.05. Find my maximum. I take 1.1 and add 0.05. 1.15, very good. So really my ostrich egg can be anywhere from 1.05 kilograms to 1.15 kilograms. That's like its average in between there. Okay? I want to do one more. Yep. Example number 7. And that's my last one. This will cover 20 through 22. What do I want to talk about? A doctor weighed the infant at 5.11 pounds. There you go. Okay? That is a small baby. Find the possible measurements. All right. So if we have 1 or 5.11, this last one is in what column? The 100th. So we take 0.01 and divide by 2. That means that our measurement can be off by 0.005. So we're going to start with doing our minimum. Take 5.11 and subtract 0.005. So we should get 5.105, right? Okay. For my maximum, I take 5.11 and I add 0.005. So we get 5.115. So this infant can be anywhere from 5.105 to 5.115. Okay, that's its like area. All right. Does that make more sense? We're good? All right. So we're going to get started on page 148, 8 to 22 all. We are doing all of them. Okay, you need to show me your calculation. All right, make sure it's there. Now I am going to tell you the odds are in the back if you want to check and make sure you're doing it right. Yeah, exactly. Thank you, Haley.